Hey, Rick Wilson here. I'm going to do a matter of time, part 3, about black holes having 2 event horizons. I'm going to start off with Coco, like I did the last video. She always seems to worm her way into my videos in the background, she's a little troublemaker. She's a little snowshoe cat. There's not very many of these. Watch some of the videos about Coco, and those are, some of them are pretty neat. Here you go, Coco. Anyway, black holes having 2 event horizons. Now, a black hole is a singularity, and I'm not going to go real deep into it because I did the other video. So if you want to know more about the black holes, go to the other video. A black hole is a singularity with such intense gravitational force that no light can escape, or nothing can escape it, not even light. That's what they claim. Now, a black hole is a singularity. It's just a little point, it's a singularity that contains so much mass within the singularity that it has a huge amount of gravity. So much gravity that nothing can escape the black hole once it gets to a certain point from the singularity. And that point they call the event horizon. So we'll draw that around the black hole. Now they always say the event horizon, no matter can escape, not even light. Of course, now I did a video about showing how under very peculiar circumstances light can escape the black hole. That's in one of my other videos, but let's forget that for now. They say at the event horizon nothing can escape, not even light. Okay, now the problem I have with that is in the movies, the spaceships that get caught near the black hole, and they always go close to the event horizon, pull some miracle and escape the gravity of the black hole and just skim the event horizon. In the movies they make like as long as you don't cross that event horizon you won't get trapped by the black hole, as long as you stay outside it. But that's a little deceptive. Okay, they always say nothing can escape the event horizon, not even light. But actually the event horizon is the point at which light cannot escape. Light, not ordinary matter, light. Now ordinary matter is trapped much farther away from that black hole than the event horizon. The reason for that is light's moving at the speed of light, and to approach close to a black hole you have to be moving very fast. Okay, but there is nothing in existence, no matter, no asteroids, no comets, no meteors, no spaceships that can come anywhere near even a fraction of the speed of light. Because as you approach the speed of light, you gain mass. And as you gain mass, then it takes more energy to get even closer to the speed of light. And my understanding is for ordinary matter to, like a spaceship, to reach, even approach the speed of light would take so much energy. It would take the energy of a sun or even an entire galaxy to force matter to that speed. So to be practical, it's never happened. Matter has never moved anywhere near the speed of light, and it never will. We will never build a spaceship that approaches the speed of light. So if you want to go with normal astral speeds for normal ordinary object of mass, say 100,000 miles an hour, just to pull a number out of the air, the point where you could not cross as you approach this black hole would be 500,000 miles out. And this would be similar to this event horizon. This is the event horizon for light. Now light can pass just outside of this and still escape. And this event horizon is as thin as a sheet of paper. This event horizon is invisible. This is the one for ordinary matter. If you're in a spaceship, this is the one you need to be concerned about, because you cannot get your spaceship to the speed of light. So you cannot come to this point here. You would be like 500,000 miles out from the black hole at the point where you would be trapped. And let's say even if you could get a spaceship up to 500,000 miles per hour, which is not going to happen, but even at that speed, that's still only a fraction of the speed of light, and the event horizon for you would be still way out in the black hole. So this event horizon is a very finite event horizon, as thin as a sheet of paper. If the photon passes outside of it, it'll escape the black hole. If it crosses that paper thin line, it'll be trapped and spiral into the black hole. And then ordinary matter, the event horizon for it is actually kind of fuzzy because it depends on your speed. So this event horizon is a bit fuzzy. So if you're moving at 100,000 miles an hour, this might be the point from where you cannot escape. If you're moving at 500,000 miles an hour, you could come a little bit closer. You could come a little bit closer and still make an escape. But like I said, this event horizon is kind of a mushy, fuzzy band depending on speed. But I'm talking about ordinary speeds that you will encounter with ordinary mass. And if you want to be practical about the speeds that are attainable, then you need to take into account this second event horizon, which is not visible, but it's there. And this is the one you do not cross. So it's not like the movies. If you're in a spaceship, you could come nowhere near the actual event horizon. Only light can come near this event horizon. Ordinary matter, like a comet or asteroid or a spaceship, has to stay much farther away from the black hole. And like I said, so there's a second invisible event horizon. So there's an event horizon for ordinary matter, and then the one that we're used to always talking about is really technically just for light, because ordinary matter is trapped way before you ever reach this. And that's it. It's a short video, just a short video, but I just want to throw this out because I see the movies and I know that it's all wrong. You can't come that close to that event horizon. You have to stay millions of miles away from a black hole if you're made of ordinary matter like I am and you are and most of us are. And that's it. We'll see y'all later.